All right. So the rules of factoring, no matter what your problem is, you look to see if it has a greatest common factor first. The only time you'll use grouping is if there are 4 or more terms. That's going to be obvious. The third thing you look for is special cases. And you've heard these vocabulary words before, but a perfect square trinomial is associated with a binomial squared. In the previous lessons, we had a binomial squared. We factored that into a perfect square trinomial. We had conjugates. We multiplied them. That gave us the difference of 2 squares. But now we've got perfect square trinomials and the difference of 2 squares, and we're factoring them into binomial squareds and conjugates. All right, just for review, would you multiply, we're going the other way, the way we did on the last exam, multiply this binomial squared. Remember that anything squared is multiplied by itself. So we would FOIL, because we're multiplying 2 binomials. These are like terms, so we combine them. And this is your final answer. It is a quadratic trinomial. I didn't tell you this before the last test, but let me show you a shortcut that you could use when you're in Coach Whitford's class, and he likes for you to use shortcuts and things, okay? You know that this means this. A shortcut is you square the first term, you find the product of these and you double it, so negative 6x times 2. And you square the last term, and you do it all in your head. He really likes when you do that, okay? He's not going to count off if you write it out and pull it out, though, okay? But that's just the shortcut. What's wrong is when you square this, and you square that, and you're finished. The middle term is their product doubled, and that's where the linear term or the middle term comes from. Now, this is called a perfect square trinomial. How do you recognize a perfect square trinomial? Number 1, the first term is a positive perfect square. Okay. Number 2, the last term is a positive perfect square. Those are easy to see. This is positive. 4 is a perfect square. Any even power exponent is a perfect square. This is positive. 9 is a perfect square. Number 3. This is kind of hard to explain. Let me explain it, and then we'll try to figure out a way to write it for number 3. The middle term is found by figuring out what you would square to get your first term, what you would square to get your last term, doubled. So 2x times 3 is 6x times 2 is 12. You say, well, that's negative. That doesn't matter. Okay, don't worry about the sign there. This middle term is the only term in a perfect square trinomial that can be either sign, positive or negative, okay? But the first and last terms have to be positive. So let me see if we can phrase that. The middle term do you guys know what square root means? Do you remember?
Yes.
What does that mean?
A definition?
Huh?
Definition.
What is the square root? How do you take square root? What does that mean?
So
What are you
you
asking
you
yourself?
multiply by itself to get that number.
Yeah. What would you multiply by itself to do that? So by taking the square root of the first term, what is the square root of 4?
2
X squared. 2
x.
x. And the square root of the last term. What's the square root of 9? Multiply them together. And double it. In other words, times 2. Okay? Double it means times 2. Squaring and doubling are different, right? Did y'all hear that? Squaring and doubling are different, right? Okay. Now there's probably a better way to word number 3, but that's the best I can think of right now anyway. This will help you determine, do I have a perfect square trinomial? Because that's the hard part. Once you discover you have a perfect square trinomial, they're so easy to factor. Let's see. First of all, let me ask you this question. Is that a perfect square trinomial? What do you square to get this? What do you square to get that? What's their product doubled? 5x times 2. 10x. Alright, so here's how you factor it. You drop that middle sign. Remember I told you it could be either. You drop that middle sign down and you square it. Because this is a perfect square trinomial and this is a binomial squared. Factor mark's easy. Because all you have to say is, what do you square to get this first term? That goes here. What do you square to get this last term? It goes here. And the middle sign drops. You say, well, what happened to the 10? That's when you find their product and double it, right? Because remember, if I wrote out 2 of those, what would outer and inner give me? Negative 10. So nothing happened to the 10. It's still in there. Agree? We agree on that? I don't think something disappeared. Because there's nothing magic, okay? Is this a perfect square trinomial? Any even power is a perfect square. What do you square to get this? 7 y. Somebody said it. Squared. What do you square to get this? 1. One's a beautiful number. It's a perfect everything. It's a perfect square. It's a perfect cube. It's a perfect fourth power. Because 1 to any power is what? 1. So it's perfect. All right. What is their product times 2? So is it a perfect square trinomial? All right. If I drop that middle sign down here and square it, there is my binomial square. Isn't that easy to factor? All the work is really right up here. So again, it's real hard to give partial credit. You know, what do you do? What do you do if something's wrong? I mean, it's just wrong. So it's really hard to do. All right, is this a perfect square trinomial? Pass all 3 tests, right? Is this a positive perfect square? Yeah. What do you square to get that?
X.
Is that a positive perfect square? Yeah.
Yes.
What do you square to get that?
4.
What is the product of them times 2? Drop the middle sign, square it. Short and sweet. You know, you do it all in your head. Is this a perfect square trinomial?
Can be, yeah.
3 is a perfect square?
It has a
Now I have messed up on every problem because I didn't ask you the first thing. What's the first thing we should have worried about? Greatest common factor. None of them had one. Does this one have a greatest common factor?
no.
No. Man, if those 16s were 18s, we'd be in good shape, right? Or if that 3 was a 4, you know. But that is not a perfect square trinomial. We'll have to try that one tomorrow with bottoms up, or Monday. Okay? Not even sure it will work. It might be prime. Is this a perfect square trinomial?
Yes.
No, it's not. What do you square to get this?
X.
What do you square to get this?
3.
What's their product doubled? 6. That's not a perfect square trinomial. And as a matter of fact, this won't even work with trial and error, which we'll talk about Monday. That one is not factorable. Well, how does that mean it doesn't have a solution? That is not what it means. We can solve anything with the quadratic formula. Okay, we can solve anything with the quadratic formula. Why am I saying quadratic anyway?
Squared.
All right, is that a perfect square trinomial?
Yes.
Mm-hmm.
Wait.
No. Why not?
Because negative can't be squared.
Because that is a negative. First and last terms have to be positive perfect squares. Can't be negative. That will not factor with trial and error. And you won't know that yet, okay? You'll know that after Monday. All right, would you try these? Does anybody have a question? See, you go down your list and you think, greatest common factor. We haven't done that at first today because we were just concentrating on the new concept. But you factor a greatest common factor, and then you go down your list. Should I use grouping? No, it can't. Is this a perfect square trinomial? Yes, okay, then it gives you a binomial square. Is there a greatest common factor over here? Like 7? No. So, can I use grouping? No. Is this a perfect square trinomial? What do you square to get this? 10 m squared. What do you square to get this? 7n. What is their product times 2? 140, right. So drop your middle sign and square it. So no matter how big the numbers get, or no matter how many variables there are, you still look at it the same way. You still do the same 3 tests, and I hope that helps you. If you go home and you try to do these and you just can't do it, you can go back and read those notes, okay? All right, now this is a review problem. Why do I call these conjugates? How do I recognize them as conjugates? They are the same except for their middle signs. All right, would you foil them? Go ahead, foil those. Now we'll do the shortcut. Good job. What's the shortcut on this one? Outer and inner are going to cancel, right?
Yeah.
So what could you just do?
The first.
First and last. Good job. What is your answer?
X squared minus 16.
Difference of 2 squares.
That's right. Oh, I don't know why I put parentheses around that. Alright, this is the difference of 2 squares. Alright, so that was a review problem. Now, we're going to get the difference of 2 squares. We're going to factor it to conjugates. Much easier to factor than it was to multiply because we already kind of know what the answer is going to be, I hope. Alright, is this the difference of 2 squares? Well, I mean, to me, I can write the steps for that, but it's just the name of it tells you, doesn't it? Is there a difference? Okay, so if this is on a minus sign, then there's not a difference, right? So if that's a plus sign, is that the difference of 2 squared?
No.
Okay. So difference, is that a perfect square?
Yes.
Is that a perfect square? Okay, good. It's the difference of 2 squares. All right, that tells me it's going to factor into conjugates. Conjugates. Conjugates have different signs. Does it matter which order you write them in? No. Okay. And then here's the questions you ask yourself. What do you square to get this?
X.
What do you square to get this?
5.
You're finished. So the hard part comes in just knowing the vocabulary, being able to recognize what you got so that you can factor them, okay? Alright, is this the difference of two squares? 16, x squared, 49 minus, okay. First of all, is there a greatest common factor? No, can't use grouping. How do I know that this is not a perfect square trinomial? There's two terms, not three. Okay, so you already told me it's the difference in two squares, so I'm going to do conjugates. They have different signs. What do you square to get 16x squared? That's right. What do you square to get 49? You're finished. Don't y'all think this is the easiest lesson we've done? Alright, does this problem have a greatest common factor?
No.
Do I use grouping? Is this a perfect square trinomial? Is this the difference of two squares?
No.
It's the sum of two squares, isn't it? Okay. Let me just tell you that the sum of two squares, and you don't hear this word much in math, is always prime. Unless there is a greatest common factor, and then you could factor it out. But still, the sum of two squares, it's prime. Alright, I don't want to mess anybody up, but I want to show you why. Why is that not got any real solutions? Why is this, why am I saying that's prime? Alright, I'm going to show you. Let's solve this like an equation. Okay? This is a bonus round, okay? This is time out, in the huddle, looking at something different, not really factoring it now. You got a question before I start?
Yeah.
Okay.
X squared.
Oh, but I put a fourth, thank you. Thanks for helping me out. It would have worked with the fourth power because it's even, but that's too much to think about. Alright, let's say that you're solving for x. What do you know to do? Gotta get x by itself.
Subtract the 4.
Gotta get x squared by itself. What do you know to do?
Divide by 2.
I square something to get a negative? That's not a real number. Okay? Again, we're still in the huddle, okay? We're not talking about factoring anymore. We're talking about solving a quadratic equation. This I is a number. It is equal to the square root of -1 because mathematicians in the early, 1500s, I don't know, before the 1900s anyway, I think maybe 1500s, they decided, I've got a quadratic equation, it's got to have some kind of solution. There's got to be something that I could say is a solution. I can't just say, well, those don't have any solutions at all. And so they defined the square root of -1 to be an imaginary number. Now, again, that's not like Tinkerbell. It's not that kind of imaginary. That's just the name of it. Why do I call you what I call you? Because somebody named you that. Right? Well, they named this a dumb thing. They call this imaginary number. In my opinion, it's not imaginary. It's right there. But that's what they called it. Okay? An imaginary unit. The imaginary number. So that, by the way, how do you get rid of a square? What's the opposite of squaring?
Square rooting.
Square rooting. Okay? So if I take the square root of x squared, what do I get?
X.
Yeah, they undo each other. Alright, here's the deal. Inside here, I've got a -1, a 4, and a 25. Can I break it up like that? Can y'all live with that? -1 times 4 is -4, right?
Mm-hmm.
Okay. What is the square root of 4? I know I'm up here, okay? But what's the square root of 4?
2.
2. What's the square root of negative 1? What's the square root of 25?
5.
If I squared a positive number or a negative number, I'd get that. There's my 2 solutions to the quadratic equation. Isn't that cool? Y'all just saw a fraction with an imaginary unit. I know that's scary. Alright, here's what I need you to do. Third block today. Where is it? Where is it? Where is it? Yeah, odd. I need to throw an I in there for bonus summer.
No, we're not probably can't do it.
We'll do another one Monday before I do that to you, okay? Don't forget Wednesday is our end of course test. Y'all have a great day.